Hello, welcome to lesson 22. This is one-digit division with a remainder and divisibility by 2, 5, and 10. Now, we learned about division and we can divide with whole numbers, although not all problems will have a whole number as an answer. Sometimes we will have numbers left over, which we call as a remainder. This is an example problem that will have a remainder. If 16 pennies are divided among 5 children, how many pennies will each child receive? Now, we don't want to make it unfair and give one child more than another child, so we're going to divide it and see how many will we just have left over. So when we do 16 divided by 5, we know that 5 can go into 16 3 times. Because when you say how many times can 5 go to 16, well, I'm going to count by 5s to see how far I can get up to 16 without going over. So that would be 5, 10, 15. And I can't go over that because then that would be 20, it would be too large. So that's how you approach division problems every single time. It doesn't matter how large your number is, you always take it one step at a time. 5 goes into 16 3 whole times, so I put my 3, now this is important. Even though this is very basic right now, this is important. 5 goes into 16 3 times. I put my 3 above the 6. Notice I did not put it above the 1. I didn't put it above the 1 because I'm not saying 5 goes into 1 3 whole times. I'm saying 5 goes into 16 3 whole times. So I want to put it over that last digit. That's very, very important to remember. If you are not organized or specific about where you put your digits or your quotient, the digits in the quotient, then it can steer your whole problem in a different direction and you will have an incorrect answer. So you do need to be careful about where you put the digits for your quotient. So if it goes in 3 times, I then multiply. That's my next step, is if I'm dividing, then I'm going to multiply 5 times 3, which is 15. Well, that's what I end up subtracting. I know you did this in 4th grade, so this is a review right now. And we'll go over the steps more often once we get into another lesson. So I subtract 15, and 16 minus 15 is 1. I can't divide anymore, and I don't have any other digits to divide by. So that's what I call my remainder. That's 3 divided by 1. Now, using that same step, I want you to go ahead and try example 1 in your notebook. 50 divided by 8. We'll set it up. 50 divided by 8. Well, I want to say how many times can 8 go into 50 without going over? Well, I'm going to show you my thought process behind this division. I'm going to start with maybe something like 5. 8 times 5. That one's usually an easy one for a lot of us to calculate, and that would be 40. Well, I think I could probably get closer to 50 because then I have to go up 10 more. So let's try 8 times 6. So if we remember, like I've been teaching you, we can do 6 times 8 is 48. It's kind of like a rhythm. 6 times 8 is 48. So 8 goes into 50 6 whole times. My 6 goes above the 0, not the 5. So if it goes in 6 whole times, I'm then going to multiply 6 times 8 is 48. That's the number I'm subtracting. Minus 48. And this is when subtraction, instead of doing a whole bunch of borrowing, it's easier to just count up from 48 and go 48, 49, 50. That's 2 as a remainder. That way I don't have so many borrowing and crossing off here in the division. That's the only time I'm definitely going to accept not necessarily showing your work because it gets really crowded in here. So 2 is my remainder. So my answer would be 6 remainder 2. Now, some of you might actually know how to prove this answer. Now, when we prove division problems with a remainder, we use the opposite operation, and the opposite operation of division is indeed multiplication. So I'm multiplying 6 times 8. I'll show you over here. 6 times 8 equals 48. But that's not 50, so where do I get my extra from? Well, that's where my remainder comes in. I actually add my remainder. So 48 plus 2 equals 50. So I know for a fact that 6 remainder 2 has to be true. This is proving my work. That's what I will expect from you on tests. Now, in this lesson, we're also going to be learning about divisibility by 2, 5, and 10. Now, these are the easiest ones and ones you probably already know without actually realizing the rule for them. If a number is divisible by 2, such as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, those are all even numbers. If it's divisible by 2 in divisibility, that means it can be divided with a whole number, by a whole number, meaning I'm not going to have a remainder. That's what divisibility is. So 50 is not divisible by 8 because I'll have a remainder. That doesn't mean that I can't divide, it just means that my answer is not a whole number. I have a remainder. So divisibility rules, meaning if I can have any number that will be divided by 2 and I will have a whole number, meaning nothing left over, that must be an even number. I want you to write these divisibility rules written down, please, in your spiral. For 5, 5's again, pretty simple. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and it continues on and on. Now, what all these numbers have in common is that every single one, no matter how far it goes out, every single one will end in a 0 or it will end in a 5. So it ends in a 5 or 0. That means I can divide it evenly if any number, no matter how many digits it has in it. If it ends in a 5 or a 0, I can divide it by 5 and I will not have a remainder. That means it's divisible by 5. Now for 10s, even more simple. It just simply ends in a 0. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It continues on and on. Every single number that is divisible by 10 will end in a 0. So that's the rules for divisibility that we have for 2, 5, and 10. We'll get into other numbers in later lessons, and those are actually really helpful because you can actually then just look at a number and say, I know I'm not going to have a remainder in that problem. If you don't have a remainder in that problem, and you mess up maybe on steps along the way and you end up with a remainder, you know that something is wrong. So these are great ways to be able to just check if you're right or not. So example 2, we're going to go ahead and look at this one. This is going to be kind of a great example, but again, we're starting basic right now. And it will get up, but these are very important to just remember, write it down, and we'll be able to use it when we go back and check our notes for anything we need to be reminded of later. Example 2, without dividing, which problems will have a remainder? So there can be more than one answer. A, B, C, and D. A is 16 divided by 2. B, 40 divided by 5. C, 45 divided by 10. And D, 15 divided by 2. So which problems will have a remainder? If we check our divisibility rules, 2 can go to 16. Well, let's see. It can, because 6 is an even number, meaning 16, the whole thing is even. That's my divisibility rules for 2. So A will not have a remainder. B, let's see, 40 divided by 5. Well, 40 ends in a 0. So if it ends in a 0 or a 5, it can be divided by 5 with no remainder. So there will not be a remainder on B. C, 45 divided by 10. Well, let's look. Divisibility rules for 10 ends in a 0. That's it. 45 does not end in a 0, so C will have a remainder. D, 15 divided by 2. Let's see. If it is divisible by 2, it must be even. 15 is not an even number because 5 is not an even number. So D is also part of your answer because it will have a remainder. Thank you very much for listening.